The Leave Plan of Room experts has found that utilizing our new 101 billion toy, it will be seemingly forever before that endeavor changes into a reality. On the slim chance that it goes as planned, the trip to Proxima B will require close to 20 years. So, reasonably, it will be a couple of years prior before we can demand whether there is sure life on that planet. The established solicitation of whether we are genuinely alone in this universe endures. The James Webb Space Telescope has found some amazingly humanesque things far away from Earth that lead us closer to the answer. Our mission for life beyond us has been uncontrolled throughout each human activity, so much so that we have a significant number of media works and hypotheses concerning this matter. Our marvel concerning our spot and misery in the universe has been consistent. It is imbued inside us to consistently look for a mate, despite how pariah-like we may be. We may get increasingly closer to the answers we truly need. However, are they genuinely the answers we are searching for, or are they simply more disturbing? Join us as we analyze the most recent discovery in the space of systems and planets on the journey to find something we probably won't be ready to see. Lights far away. Subject matter experts have found what could be the most weighty discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting theoretical inquiry was raised about the abilities of our technology. The question was whether, later on, our telescopes could detect artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was identified to be impeccably locked with an extremely permanent day side and night side, like our moon. A theoretical creative improvement on Proxima B could move power and energy from the day side to the night side using photovoltaic cells that make power from starlight. Therefore, in a paper with Manis Vling as one of the scientists, it was shown that a colossal concentration of the day side by solar chargers could be connected with future telescopes. Since JWST was further developed, it would allow us to extend our search for artificial lights on exoplanets like Proxima B. Now, the reality that the James Webb Space Telescope did precisely that in 2024, utilizing its higher awareness and greater extent of abilities, is momentous. The JWST could have found the lights we were looking for and perhaps flung us into another massive rush of human activity. Above all, we ought to dive into the universe of planets and exoplanets to sort out how this was indeed even conceivable. James Webb's mission investigates Proxima B and its secrets. Starting from the beginning of recorded history, people have pondered the possibility of the universe, what we are, where we come from, and where we go. These are conventional yet remarkably troublesome requests that mankind has tried to answer. When we acquired awareness in the hour of excellent mechanical development, one considers whether we are any nearer to noting these solicitations. If you were to ask a philosopher, he could say we are still at level 0 of understanding ourselves in the universe. Anyway, ask a space master the same inquiry and watch him take full advantage of his energy as he races to let you know the latest revelation people have made about the universe using their smart devices. These instruments, albeit not given much thought by the customary public, are straightforwardly an impression of human activity itself. We now have the world readily accessible, and it's time we push forward and get the universe at our fingertips too. One such strategy for doing that was determined by researchers and space specialists. Through the technology we tackle, a particular making of that technology is now responsible for the new discovery of what may be light on another planet light-years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the customs of human undertakings into space to address some ever-present questions. Are we alone? Who's out there? Where do we begin and where do we end? This infrared space science device has already begun watching out for these solicitations. Notwithstanding the truth that, at first, you could get yourself asking what Proxima B is, Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri SE. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could befuddle you, but don't worry. This text will settle all your burning questions. Super-Earths are a class of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are really one of a kind. They can be made of gas, rock, or even a mix of both, and their sizes can vary from twice the size of Earth to several times its mass. Regarding Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planet group. The first possible evidence of an exoplanet was considered to be found as soon as 1917, although it produced little interest. However, confirmation came in 1992 with the first confirmed discovery, which left experts stunned. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These eminent discoveries are surrounding an M-type star. To understand the M-type star, you need to figure out the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the interconnecting region of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have incredibly low luminosity, and since luminosity is one of our main tools for planet detection, red dwarfs are not so easy to notice. These inconspicuous stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, thus getting their name. Also, regarding Proxima B, its mass is known to be comparable to 1.07 Earths. Curiously, it only requires 11.2 days to complete one orbit of its star compared to our 365.25 days. You can gauge the size of the star Proxima B is surrounding. Incredibly, under the evaluation of the whole electromagnetic range, the star has a total luminosity of as little as around 1.6% that of the Sun. Besides, in the visible light range, its sparkle appears to diminish more. It only shines 5 to 6% of the Sun's brightness, emitting an even lesser amount of light energy compared to the Sun. More than 85% of its radiated energy is infrared radiation, circling about 0.045 to 0.056 astronomical units from its star. Proxima B's discovery was reported back in 2016. You could inquire as to why Proxima B, with a million stars, planets, and universes, is of such focus. Well, there are a couple of reasons that add to the noticeable interest cosmologists have here. In particular, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a simple blip. Hence, why Proxima B, our nearest known star, is high up on the priority list right now. It is part of the triple star system called Alpha Centauri. Moreover, despite Proxima's luminosity being incredibly low, the system itself appears as one of the most brilliant celestial bodies in the night sky, just behind two others called Sirius and Copus. However, the most charming thing about Proxima Centauri B is that it could really be habitable, as it falls within the habitable zone. The possible results surrounding the star are unending, and hence, astronomers have taken on the task of exploring the depths and limits of the star's true potential. That's where the James Webb Space Telescope comes in. The four vital objectives of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study the universe's formation and evolution, figure out star and planet formation, and focus on planetary systems and the origins of life. As the JWST continues its examination of the said exoplanet, we move closer to the summit of these missions. From looking for exoplanets to searching for extraterrestrial life, so what exactly is said, one could inquire. Considering that people have always been a curious species, inspecting and getting into literally everything that moves and doesn't move, it makes sense that a mission like SETI showed up on such a huge scale. Envision that God has coordinated an excellent, huge undertaking, but with a touch of gold. We are entrusted with being on the lookout for signals. More specifically, electromagnetic whispers from human civilizations beyond anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, resembles the world's most high-stakes game of hide-and-seek, with our planet as the seeker and the vast universe as the seemingly endless hiding spot. It is one of those fields where researchers are like advanced Sherlocks, tuned into radio waves and scouring for that subtle, "we are not alone" signal. This cosmic sneaking around began in the 1960s. Frank Drake, a notable astrophysicist, was among the first to detect radio transmissions from the stars. It was a memorable moment, but no aliens showed up at his door. Now, as you might have guessed, looking for something this enormous takes patience and can span many years. The search for extraterrestrial life has captivated humanity for centuries. With each new technological breakthrough, we inch closer to answering one of the most profound questions. Are we truly alone in the universe? In addition to the search for life through telescopes like the James Webb Space Telescope, there are a variety of other missions and technologies being developed to explore the vastness of space. These advancements could revolutionize our understanding of life beyond Earth and perhaps even lead to the discovery of intelligent civilizations on distant planets. One such breakthrough in space exploration is the development of artificial intelligence, AI, systems designed to aid in the analysis of astronomical data. The sheer volume of data generated by instruments like the James Webb Space Telescope is staggering, and without the assistance of AI, it would be nearly impossible to sift through the noise and pinpoint significant findings. AI is being used to identify potential exoplanets, analyze their atmospheres, and even search for signs of life. It can also help scientists detect patterns or anomalies in the data that human researchers might miss, speeding up the process of discovery. Another promising area of research is the development of biosignature detection techniques. Scientists are exploring a range of potential biosignatures, molecules or patterns that indicate the presence of life on distant exoplanets. These could include oxygen, methane, or other chemical compounds that are associated with biological processes. Detecting such signs would provide strong evidence for the existence of life beyond Earth. The challenge, however, is that many of these molecules can also be produced through non-biological processes, so distinguishing between the two is not always straightforward. In addition to studying exoplanets, researchers are also focusing on moons within our own solar system that might harbor life. For example, moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, have subsurface oceans beneath their icy crusts. These oceans may contain the necessary conditions for life to exist, such as liquid water, warmth, and organic molecules. Missions like NASA's Europa Clipper, set to launch in the 2020s, aim to explore these moons in greater detail, searching for signs of microbial life or conditions that could support life in the future. The potential discovery of extraterrestrial life would have profound implications for humanity. It could challenge our understanding of life itself, prompting us to reevaluate our place in the universe. It would also raise important philosophical, ethical, and practical questions. For example, how would we respond if we discovered intelligent extraterrestrial life? Would we attempt to communicate with them, or would we take a more cautious approach? And if we found microbial life on another planet, what would that mean for our understanding of the origins of life on Earth? These questions are not just for scientists to consider. They are questions that society as a whole will need to address. The discovery of extraterrestrial life would also have significant implications for space exploration. If life can exist on other planets or moons, it could pave the way for future human colonization of those worlds. For example, if scientists were to discover that Mars once harbored microbial life, it would make the planet an even more attractive target for future human missions. The presence of life would indicate that the planet had the necessary conditions for life in the past, which could make it more suitable for future human habitation or the search for resources. Furthermore, the discovery of extraterrestrial life could fuel interest and investment in space exploration. Governments and private companies may be more motivated to fund missions to distant stars and exoplanets, driving innovation and technological advancements that could benefit other sectors as well. As more powerful telescopes and spacecraft are developed, humanity's ability to explore the universe will continue to expand, bringing us closer to answering the age-old question of whether we are alone in the cosmos. However, the search for extraterrestrial life is not without its challenges. The vast distances between stars and planets present significant obstacles to direct exploration. Even with the most advanced technology, sending spacecraft to other star systems could take decades or even centuries. In the meantime, astronomers will continue to rely on powerful telescopes, AI, and other technologies to search for signs of life. While these tools are incredibly advanced, they still have limitations, and much work remains to be done before we can definitively answer the question of whether we are alone in the universe. As humanity continues its search for life beyond Earth, the field of astrobiology, combining biology, chemistry, and planetary science, has become central to understanding how life might arise elsewhere in the universe. Researchers are investigating the fundamental building blocks of life, such as amino acids and other organic molecules, to determine whether the conditions for life exist on distant planets or moons. The discovery of complex organic molecules on comets, asteroids, and in the atmospheres of distant planets raises the possibility that the essential components of life are more common than we once thought. The concept of the habitable zone around a star, also known as the Goldilocks zone, is critical to the search for life. This is the region where temperatures are just right, neither too hot nor too cold, for liquid water to exist on a planet's surface. As our understanding of the habitable zone expands, scientists are now exploring the idea that life could exist in environments previously considered inhospitable, such as the subsurface oceans of icy moons like Europa, Enceladus, and even Titan. These moons, despite their cold and distant nature, may have the necessary conditions for microbial life to thrive beneath their icy crusts. In addition to searching for biosignatures, researchers are also considering the possibility of detecting technosignatures, evidence of technological activity from alien civilizations. This could include radio signals, laser emissions, or even artificial structures on distant planets. As our technology improves, the ability to detect such technosignatures is becoming more feasible, especially with the development of highly sensitive instruments like the next generation of radio telescopes and spectrometers. While the search for extraterrestrial life has progressed tremendously in recent years, many challenges remain. The vast distances between stars and the limitations of current spacecraft mean that we are still far from directly exploring other worlds. However, as new technologies emerge and our scientific knowledge deepens, the possibility of discovering life beyond Earth becomes more tangible. The ongoing exploration of the universe may one day lead to the profound revelation that we are not alone in the cosmos.